Okay, welcome back, students. In this video, we're going to talk about another gas law. This one is called Avogadro's law. You guys remember from last year this name, Avogadro? What did you guys learn last year? Good. Avogadro's number. What is Avogadro's number, guys? 6.02 times 10 to the 23rd? Yeah. Right? Okay. Hey, same guy. But now we're going to learn the gas law that he came up with, okay? So in your books, be following along if you're watching the video with the guided notes. Fill out your guided notes as we go through these slides. Okay, the guy's name is Amedeo Avogadro, and he lived late 1700s, early mid 1800s. He was Italian. He experimented with different gases. And this is how he came up with Avogadro's number. And actually they called it Avogadro's number in his honor after. Okay. So you need to write down what Avogadro's law is. Here's what it is. Okay, it states that equal volumes of gases, of all gases, at the same temperature and pressure, have the same number of molecules in them. So if you have equal volume of all gases, and you keep the temperature and pressure constant, you're going to have the same number of molecules in those gases. Equal volume, equal number of molecules. Okay, I've got a diagram at the bottom of this slide that shows, and hopefully I guess helps you understand a little bit better what Avogadro is saying here. Say we have a balloon full of helium and a balloon full of nitrogen and a balloon full of CH4, which is methane or natural gas. All different gases, right? But let's say we have equal volumes, like Avogadro was saying. You got to have equal volume of those gases. Say we have 22.4 liters of helium, of nitrogen, and of methane. Well, Avogadro said if you have equal volume, the number of molecules will be the same. So the number of gas molecules will be the same. And what did he find, guys? How many molecules do we have in 22.4 liters? 6.02 times 10 to the 23rd molecules. That's where Avogadro's number came from. That's how he discovered it. He was experimenting with gases. And that's a little bit, I don't know, helium's very small. CH4, I mean, that's a larger molecule, right? But regardless of their sizes, if you've got the same volume, you've got the same number of molecules of that gas. And that goes for any gas that you have. If you have 22.4 liters of it, you have Avogadro's number of molecules, which is pretty cool. All right, let's explain it in terms of the math. Avogadro's law. So it says here, there's this equation, V equals NK. And then it says where N is the number of moles. This is new, guys. You're going to see this. N equals what? Number of moles. Okay? And K is the constant. So volume is equal to the number of moles times a constant. If we rearrange this equation and solve it for constant, we get volume divided by moles is equal to a constant. So volume divided by moles is equal to K. I don't know what that constant is. Let's say it's 10. Okay? If volume was to go up, what would have to happen with the number of moles in order to keep this 10? It would have to go up as well. Good job. We see that? Okay. Also, what if volume went down? What would the number of moles have to do? Would have to go down in order for it to be a constant. And so there's our relationship there. In other words, the volume of a gas is directly related to the number of moles of a gas. So volume is directly related to the number of moles. I think we get this directly related, inversely related relationships, right? But let's see. If I put more moles, what's going to happen to volume? It's going to go up. What if I decrease the number of moles? Volume will go down. Yeah, so if one goes up, the other one goes up. If one goes down, the other one goes down. Okay, well, Avogadro graphed this. He put the amount of moles on the x-axis and the volume of the gas on the y-axis. And look at what happened. It was a linear relationship. This line is straight, and it's got a positive slope. So what does that tell you? If moles goes up, so does the volume of the gas. Okay. Guys, I hope that you remember a little bit about graphs and how they work. The dependent variable always goes on the y-axis. Isn't volume dependent on how many moles you put in it?
Yeah.
Sure. So the dependent one goes here. So volume will go on the y-axis there. Okay, a summary of Avogadro's law, and then we'll go through a practice problem after this. Summary, number one, it says there's a direct relationship between volume of a gas and the number of moles of a gas. So there's a direct relationship between volume and moles. Now, of course, this is only true when pressure and temperature are constant. You can't be changing the pressure and temperature at the same time you're doing this. So. Okay, a useful equation for Avogadro's law is this one here. This is the one we're going to use most of the time. V1 over N1 is equal to V2 over N2. I know we've gone over this a lot, guys, but what is this? What are these ones telling us here? Good. Good, Braden. That means initial, right? So whatever your volume and number of moles is initially goes with 1. What are the 2's telling us? Final. So sometimes in these problems you've got to read and determine what it is initially and what it's going to be finally. Make sure you put the variables in the right spot. Make sense, Ethan?
Yes.
Right.
Perfect sense.
Perfect sense. Great.
No.
Okay, I've got a practice problem. Only one for Avogadro's law. So please pay attention. This one's a little bit more complex than the ones that you'll see on the worksheet or on a test. But I wanted to show you this one anyway, okay? Let's read it and go through it. I'm going to show you how I solve problems like this. Okay, so let's read it first. Suppose we have 12.2 liter sample containing 0.5 moles of oxygen gas at a pressure of 1 atmosphere and a temperature of 25 degrees Celsius. If all of this oxygen were converted to ozone at the same temperature and pressure, what would the final volume of ozone be? So there's a lot going on here. But here's how I would break this down. Okay, I like to underline what they give us. So 12.2 liters is our volume. 0.5 moles is going to be N.
What is N?
Okay. Pressure of 1 atmosphere and a temperature of 25 degrees Celsius. And then this last sentence, it says same temperature and pressure. So is temperature and pressure changing, guys? No. So I don't need, if they're not changing, whoops, that was my moles. If they're not changing, I'm going to cross them out, okay? So pressure and temperature are canceled out. So what's changing here, Ezra?
What's changing?
Oh, 2 to 03.
Yeah.
Is the volume going to change?
No.
No.
We want to find the new volume. Is that changing?
Yes.
Yes. Volume's changing.
The so's 02 to 03.
But the gas is also changing. It's going from O2 to O3, right?
Yeah.
Okay. So if all of the O2 is converted to O3, which is ozone, let's write an equation for that. O2 is being converted to what? O3. Is that a balanced chemical equation?
Yeah.
Nope. How do you balance it, guys?
2 and 3.
Yeah, the lowest number that both 2 and 3 will go into is what? 6. So if we put a 3 here and what would we need to put here? A 2. So let me go through this. How many moles of oxygen do we have? 3 moles of oxygen gets converted into how many moles of ozone? 2. Okay. And if we start this with how many moles of oxygen? 0.5 moles of oxygen. So let's do the stoichiometry on that. 0.5 moles of O2. How would we switch that to moles of O3?
Just divide up the 6.
Okay, let's do a conversion factor. If moles of O2 is on top, where's it got to go? It's got to go on bottom to cancel out. What are we trying to go to, guys? Moles of O3. Where do I get these numbers from? The balanced equation. How many moles of O2 do I have? 3. How many moles of O3 do I have? 2. So how many moles of O3 will I have in the end? My moles of oxygen cancel out. Half of 2 is 1. Divided by 3 is 0.33 repeating. Moles of O3. Okay, so now I have moles of oxygen. What we started with was 0.5. And now I've got moles of ozone that we're ending with. So I've got moles initial and moles final. Let's write down that equation for Avogadro's law. What was it?
V1 over T1.
V1 over
N1.
N1, yeah, is equal to V2 over what? N2. Yeah, Ezra, it's very similar to which other gas law did we talk about that's similar to this? Charles' law. Charles' law is V1 over T1.
Oh, yeah.
But this one's Avogadro's goes off of moles, so instead of on the bottom we're going to put N. Yeah, they don't use M. They just it's N is the symbol. Yeah. Okay, let's plug in. What's V1, guys? 12.2 liters. Okay, 12.2 liters divided by what's N1? Yeah, we had 0.5 moles. 0.5 moles. That's going to be equal to what's V2? We don't know that one. Divided by what's N2? 0.33. So 0.33 moles. All right, guys, let's use our math skills. How do we solve for V2? What do you think? Times by what? Good. We got to get a V2 by itself. Let's times both sides by 0.33 moles. Okay, whatever you do to one side, you got to do to the other. Okay, over here, the 0.33 moles divided by 0.33 moles is 1, right? So we can cancel it out. On the left side, our moles will cancel out. So we've just got 0.33 times 12.2 and then divided by 0.5. Are you guys getting that V2 is equal to 8.05, which rounds to 8.1. 8.1 what? Liters. Good. Volume in this case was measuring in liters. So 8.1 liters. Let's see if we got it right. And we did. Okay. Most of them won't have the stoichiometry, guys. The ones that you're going to do in the book, you're just taking this equation, plugging in initial volume, initial number of moles, final volume, and final number of moles, and solving for the one they don't give you. Does that make sense? Okay, so before I end the video, let's review Avogadro's law. As the number of moles goes up, what happens to volume? Goes up. What kind of relationship is that? It's a direct relationship. This is a gas law that's really kind of, I don't know, it's common sense to me, but we're not going to do a lab on it. But here's a demo. If I wanted this volume of this balloon to go up, what do I got to do? Put more moles of gas in it, right? So how do you do that? You just blow it up. How do you make it bigger? How do you make the volume go up? More moles in there. Now, what if I wanted to make the volume go down? You got to take the moles out. So, I mean, that's basically Avogadro's law right there. Any questions? Avogadro's law. N is equal to what? N equals number of moles. Okay. So we've learned enough, guys, to do a worksheet in the workbook. It's called Avogadro's Law Worksheet. So please turn there and complete that.